Okay, student notes 5.5, sum and difference properties, day 3. Okay, here's yet another way that we can use these sum and difference properties. And today we're going to really be focusing on equations. So if you look at the bottom of your page, it says when solving equations, you can work on both sides of the equation. That's a good thing. When proving identities, which is what we were doing before, you can only work on one side. So just to make it really clear here, we're not solving these identities. We're not proving these identities. We are solving the equation for x. And if you notice, we've got general solution and we've got particular values. So we're going to be using things that we did in chapter 4 into this as well. Okay, so first off, if you notice on the left-hand side, this looks like our sum and difference formula. So if you don't already have your blue sheet out, I want you to pause the video, go ahead and get that out. Okay, and it looks like we've got a cosine A, cosine B, minus sine A, sine B. So I look on my formula sheet. It's not blue on here, but yours would be blue. And that looks like cosine A plus B. All right, so when I replace this, okay, this is a use for an identity other than just proving it, but for actually using it in an equation. So we've got cosine parenthesis x plus pi over 4. I do not suggest you try to memorize these. They're all way too similar to each other. And if you accidentally mess up and make this become x minus pi over 4, you're going to get the wrong answer here. So you don't have to memorize these, so just don't even try. It's not a big deal. Okay, now this is very similar to something that we had before, and this is something you should be doing without a calculator. You can always go back and check it later, but we want exact values. We don't want rounded numbers here. If this 1/2 were something else like 2/3, we would have to use a calculator. But since it's a nice value like 1/2, we don't have to. And let me show you why if you haven't figured this out. Okay. The angle that I'm taking cosine of, which in this case is x plus pi over 4, is equal to the arc cosine of 1/2. Now this is a principal value situation going back to the last unit. And what is arc cosine of 1/2? Give you just a few seconds to think about that. Okay, that's going to be 60 degrees or pi over 3. And since we're doing general solutions, I'm going to go ahead and write plus 2 pi n. Now remember, with general solutions, with sine and cosine, we always have a second one. So let me go ahead and write, before I even continue this at all, I need to find what the other value will be. Now there's only one principal value, but there is another value that when you take cosine of it, you also get 1/2. So let me just remind you of how to really think through this logically and come up with it. Okay, pi over 3 is in the first quadrant. That's where the principal value is when we're taking cosine and we get a positive ratio. What is the other quadrant where cosine is positive? I'm not talking restricted range here. Restricted range is what you do when you try to find the principal value, particularly when the ratio is negative. What quadrant do you go to find the principal value? So I'm not talking about restricted range. I'm just saying what is another quadrant that when I take cosine of that angle, I will get a positive ratio, in this case positive 1/2. Okay, that would be quadrant 4. So what would 60 degrees or pi over 3 be in quadrant 4? It would be negative pi over 3. Now you could here take the long way around and write something like 5 pi over 3. That would be perfectly acceptable here. I'm going to take the easy way and just write it as negative pi over 3. Now some of you memorized how to come up with this other one. And for cosine, you memorized that you just change the sign from positive to negative or from negative to positive. If you can keep on remembering that, that's fine. That is not something, though, that you have to memorize. You can always just go back and look at it here. Okay? So with all that being said, let's continue to solve for x and finish part A. So what I'm going to do here is I'm going to just do the logical algebraic step, which would be to subtract pi over 4, right? Because that would just give me x. Now you are going to have to do a little bit of fraction work here. So think about what your common denominator would be? It would be 12. So this would be 4 pi over 12 minus 3 pi over 12. That's 1 pi over 12. I'm not going to spend a lot of time on how to go over that because this is something you should already know how to do. And then plus 2 pi n. Okay, this is one of my general solutions. Okay, over here, same thing. Minus pi over 4, minus pi over 4. And so my other general solution, in this case, negative 4 pi over 12 minus 3 pi over 12, that's going to give you negative 7 pi over 12. And then plus 2 pi n. This is my other general solution. Now, both of these solutions that are written here are things that I should be able to plug in for x here and here and get a true statement. You could go through and check that. It would be something you would need a calculator for, or you would need to use the cosine a plus b formula. Okay, but you'd have to do quite a bit of work to actually check that. I would actually encourage you to continue this problem all the way through and then check your final answer in the calculator, and I'll mention how to do that at the end. Okay, so that's the answer to part A. Okay, part B is saying the particular value. So look at your two general solutions. If you did these right, then look at the two. If they're both positive, just write them in order. If only one of them's positive, well, that's your first positive answer. And I'm doing positive because it tells me to go in the first quadrant, okay, between 0 and 2 pi. All right, now negative 7 pi over 12, not in the first, I'm sorry, I said first quadrant, I meant first revolution. It's not in the first revolution, but if I add 2 pi into it, okay, or if plugging in a 1 in for n, either way, if I do one revolution around from negative 7 pi over 12, this would be like adding 24 pi over 12, okay, if I kind of did this off to the side. I'm not adding pi here, okay, but I'm adding 2 pi. So what would be negative 7 plus 24? It would be 17, okay? So that's going to give us 17 pi over 12. Now, if I were doing the first three values, which is what we have been used to, I would just keep going. I would add 2 pi. However, it just says to go between 0 and 2 pi. Now, at this point, if I add 2 pi to pi over 12, I will be past 2 pi, which should make sense. So I'm actually done here. I don't even have to come up with a third one. Okay? All right, let's try an example of tangent. Cosine and sine both work very similar here. If you remember your general solutions well, then this really shouldn't be that much more difficult. If you really have forgotten about what to do with general solutions, then you should go back and rewatch that video. Okay, example 2, tangent. Now, if you're not sure if this, rewind. Okay, if you are not sure if this is tangent plus or minus, okay, then go through and look at your formula sheet. That's what it's there for. Okay, it looks like if I compare what's on my paper to what's on my formula sheet, I should be looking at this. It's in the subtleties of the pluses and the minuses. So it looks like it's tangent A minus B. Okay, so what this means is the whole left-hand side is going to simplify to tangent A, which is 2x, minus tangent B, or minus just B, sorry, which is just x. Now, in this case, it works out quite nicely because 2x minus x is just x. So that's going to make the end of this problem much easier to deal with. Okay, so now the angle, what I'm taking tangent of, and I say angle, I'm in radians though, all right, is equal to the arctan of negative root 3 over 3. Okay, so you got to think back to whether this should be 30 or 60. And if you can't remember, you can always draw a triangle, all right? But keep in mind that this is the same as negative 1 over root 3. So if you draw a triangle with your theta or your x, the opposite being 1, the adjacent being root 3, that would make obviously the hypotenuse 2. you can see that this is a 30, okay? It's easier to look at it with the unsimplified radical than it is the simplified radical. So the reference angle here is 30, but because I have a negative, I do have to think about restricted range. All right, and just to kind of review this for tangent, restricted range for tangent is like the restricted range for sine, or arctangent has the same restricted range for arc sine. So I should be going to the fourth quadrant, okay, for negative. So that's going to, my principal value here is negative pi over 6. All right, and remember for tangent, it's not plus 2 pi n, it's just plus pi n, because pi is the period for tangent and cotangent. And I don't have a second general solution, and I don't have anything else to do to solve for x, so that's what I mean by we kind of lucked out here with this 2x minus x. If it had been more complicated, might have had to do another step here at the end. All right, now let's go to B. If you have found the general solution correctly, B really isn't too bad, because what you're doing is you're trying to find all the answers in just the first revolution. Now, negative pi over 6 is negative, so we've got to add pi in this case, or plug in a 1 for n to even get our first value. So what is negative pi over 6 plus pi? Okay, or this would be like a half revolution around the circle. Okay, that would be 5 pi over 6. And if I add pi again, I will get 11 pi over 6. And if I add pi again, I will be outside of the first revolution, or past 2 pi. So I stop here. Okay, now I did say that there was a way you could check this in your calculator. If you remember from past algebra classes, on any time you have just one variable, you can take your original problem, plug it into y1, plug your other side into y2, find the intersection. That would be very difficult to probably type in here, but what wouldn't be difficult is maybe to type it in at this stage in the game. And so you can find the intersections. This is the way we did this in the calculator before. On problem number 1, we could do the same thing. I could put the whole left side into y1 and the right side into y2 and find the intersections, although it'd probably be easier to do it at the general solution stage of the game, or even at this stage of the game. Okay? Bring your questions to class.